everyone for joining us today on the Traefik Islamabad meetup. And if you haven't explored Traefik 2.5, today is a chance for you to explore what's new in it. I have a very wonderful feelings of this 2.5. I've tried it out and I've watched few of the session that Jakub does on the traffic side and really expressed by the progressive delivery feature and bunch of other features as well. Also, the traffic is an Ingress controller for the Kubernetes, one of the most famous one. And if you've been into the migrating your cluster to the Kubernetes 1.22, you see a lot of the deprecated APIs are removed. And that's a really a pain point for a lot of the people. So today, Jacob will tell you how the traffic ecosystem evolved itself to the newer set of the API. So you don't need to panic or don't need to learn or don't need to worry about these kind of stuff as well. So Traefik 2.5 is having a ton of new feature. Hope we cover a lot. This is a hands-on session today. And thank you very much, Jakub, for joining me from Poland and talk about this Traefik 2.5. Jakub is a wonderful product specialist at Traefik Labs and wonderful friend of mine and a wonderful community member inside the Traefik ecosystem. So over to you, Jakub, and talk us about the newest releases in 22.5.
Yeah. So hello everyone. Thanks a lot, Sam, for introducing me. Thanks a lot for inviting me to the meetup once again. As you already mentioned, I'm going to talk about Traefik 2.5 that has been released some times ago already. So I'm going to cover crucial features. And so can we start?
Yes, absolutely.
Yeah, let me share my screen. So you should be able to see my screen, I think.
Yes, absolutely.
Yes, so today we are going to talk, as we already mentioned, about what are the new features in 2.5. Traefik Proxy 2.5. As you can see, there are a lot of changes related to the Kubernetes release 1.22 with a Consul Connect integration and lots of other features. So some of them we are trying to demonstrate to them. Some of them you can try to test on your own site. So let me briefly introduce myself. I'm Jakub Hajek. I'm a product adoption specialist. So I work for Traefik Labs. I'm a technical person. What I'm doing, I work with customers. I help them to adopt Traefik Proxy and Traefik Enterprise because there are two products that we are supporting. I'm also involved in the community, so I'm trying to help people in the community Traefik.io forum, trying to solve some of their issue. I'm involved in the GitHub issue triage and try to reproduce the issue. So you can contact me in case of any issues, any questions related to Traefik and other product that Traefik Labs released. I'm also a Kubernetes enthusiast. I like very much the Kubernetes. In my opinion, it's a, let's say, new Linux distribution because I was a sys administrator for lots of years and I was managing servers, let's say manually, bare metal machines. But now for me, Kubernetes is like a new distribution that you just need to learn and you need to start using because it's nice, it's cool. And as Sam mentioned, I occasionally do some talks, tech talks. I'm also making some workshops. So recently I gave a talk about advanced load balancing of Traefik. So I presented a couple of the features that are in Traefik in general related to the load balancing. So you can find it on the YouTube. Yeah, and of course I'm a dad, so when I'm not working, I'm trying to spend my time with my son or practice any sport activities that we also discussed with Sam before starting the meetup. So let's move forward with some technology stuff. So what I'm going to cover today, and so those are the crucial features that were released in Traefik 2.5. So related to the Kubernetes API changes, to the Consul Connect, local providers plugin, TCP middlewares, and advanced load balancing that are related to the nested health checks. And of course, HTTP3 that is added as an experimental feature in Traefik. Of course, there is much more changes, but that are the most, I would say, important, the most that you as a community, as Traefik user, you can see what's happened. But I strongly encourage you to see what's happening on our GitHub, so you can see how many other bug fixes, how many minor changes were also added to 2.5, and also 2.5 were released a couple of months ago, and now it's 2.5.4. This is the latest release. So yeah, lots of bug fixes and minor changes were added since the initial release of 2.5. So today I'm going to do some of the some theoretical slides just to explain what has been changed, but I would like to also give you a demo, and if you would like to clone the repository, that's the link. You can clone it, and you can use it later on for your further tests, and the feedback is more than welcome. So what's the major change in regards to the Kubernetes? So as you can see, Kubernetes has been 1.22 is already released. In many companies migrated to that version. And prior to that version, there were a lot of deprecated APIs, extension v1 beta 1 and networking v1 beta 1 for Ingress and for Ingress class. So prior to that version, you were able to use it, those APIs, even if they were deprecated, you were able to use it. However, with the 1.22, those APIs are already removed. So that's the very important thing that you should keep in mind, that there are no such APIs, and you need to migrate to the networking v1. And if you plan to use 1.22 Kubernetes, you can use Traefik 2.5, because Traefik 2.5 is already utilizing those APIs, and it should work correctly. And I will show in a demo how to use Ingress and Ingress classes objects in Traefik 2.5. So as you can see, the spec also has been changed. So it is previously we had a backend and we have a service name and service port, but now in the newest spec we have a backend and we have an attribute service that has another attribute's name, port and its number that refers to the port of the service. So that's definitely something you should keep in mind, that if you try to use Traefik on 1.22, it has to be 2.5. And more explanation can be found on that tweet that comes from Jerome. So he explains why these changes are happening and what are the impact on your environment. So let's move forward to the Consul Connect, because yeah, as you know, Consul Connect is a service mesh, and it's already Traefik Proxy can now natively speak to that service mesh, and yeah, probably you know the Consul as a key value data store, but now it's more there are more features such as Consul Connect that can provide real service mesh for your services deployed on the Kubernetes. And the connection is encrypted using MTLS, so all the transmissions are encrypted, as you can see here in the diagram. And I encourage you to see, because I'm not go in details in regards that feature, but you can see. Let me copy that link, and you can explore it on our blog, and to go through the examples that are already created by one of our team members, Ryan. He explained in details how to use Consul Connect with Kubernetes. So there is a good example, and you can see how to play with that feature. So it's step-by-step implementation using the Consul on Consul Connect and Kubernetes. So I encourage you to go through the tutorial that is very powerful and very informative, because there are lots of nice features and a good explanation why you should use some of those specific features. So Consul Connect in 2.5, it's just a natively integrated into Traefik. Going further, we introduced TCP middlewares, but before going into TCP middlewares, I would like just do a quick recap. What is the middleware in Traefik? So in Traefik, you have a middlewares that can tweak request on response that is coming to Traefik and going back to the service. And the same can be done with a response. So Traefik can modify that values there, and there are no any runtime changes, so it cannot modify the routing, it cannot modify the service, but you can think about it as a, for example, one of the basic middlewares might be a basic authentication, rate limits, circuit breakers. So those are running on the HTTP. But in 2.5, we implemented new middleware that is called that is running inside the TCP router, and it's called IP whitelist. So this is something that might be used for authorization. So you can list the IP addresses that can be whitelisted to hit that specific router, and definitely more middlewares will be implemented. So you can see that issue on the GitHub because there is more information related here. But what I would like you to remember from that slide, that there are new type of the objects, TCP middlewares. So new CRD is implemented if you know Traefik. So that's something you should keep in mind. What else is implemented? So we implemented local and provider plugins. So it's before that you could use a middleware and the plugins as a middleware. So the community can provide the middlewares, and it might be released through the GitHub pilot. So one of the most popular are the JWT, JOT, scale on demand, and fail to ban. But again, it has to be done through Traefik pilot. But now it can be done locally. So you can have a directory locally, and you can use plugins loaded from your local system. And the same can happen with a provider plugins. So one of the example is a service fabric that is deployed, that is developed one of our friend, and it can be done as an external plugin. So now having that plugin, you can create your own providers in Traefik. So it's cool feature because we don't know what our community will provide, because you have that possibility to code your own plugins on own providers. And in my demo, I will show the basic example using plugin provider using Docker Compose. So that's very cool feature that allows community to provide their own features into Traefik. So let's go further. And that's the feature that I like very much, because it's called it's part of the advanced load balancing, and it's called a nested. Nested health checks. It works on the weighted round robin traffic service. So as you can see, it can work on the nested structure, because we can have a couple of the services. Let's say WSP service that has its type is awaited, and traffic can be sent to WSP1 on WSP2 based on those weights. So if we go further, we can see that here we have a health checks also, right? So if that service is unhealthy, Traefik now is able to detect that feature, that issue actually, and will not pass the network traffic to that unhealthy service. So it's happening using that nested structure, and I will try to demonstrate it in my live demo. So what is important here currently is only available as a file provider, so you cannot use the CRD for that. but we are working on it to implement that feature as a file provider. It's as an Ingress root, as a CRD. You can still use it in Kubernetes, but you need to create the dynamic configuration using the file and create config map in Kubernetes to upload that file. And that feature can be used in different, I see many use cases, because you can connect more than one Kubernetes cluster or a Kubernetes cluster and any Docker Swarm cluster, or even legacy servers, even bare metal servers. And you can use the endpoint and route the incoming network traffic to, let's say, to one of your bare metal servers, VMs, or any other services. You will see in a second that in my live demo. And last feature that is worth to mention is HTTP3. So as you can see, it's added as an experimental feature, and I pasted a link here to explore more what is inside the HTTP3, because that's the new protocol. It's still in draft mode, so we don't have the fully we don't have an accepted specification yet, but we started to implement it, and you can use it in Docker Compose, with Docker Compose with Kubernetes. In Kubernetes is much more tricky because it uses UDP, and you need to create more than one service type load balancer with a two type of the protocol. So it's quite tricky to implement in Kubernetes. In Docker Swarm, it's, let's say, easy to test it. And yeah, it's the new protocol, and it's quite fun because we still haven't explored everything in HTTP2, but we started to implementing HTTP3, and the major difference is that HTTP works in the layer 7, and HTTP2 it uses TCP, but for HTTP3 we can use UDP as a foundation, so it should be more faster, and it provides shorter loading times for that protocol. So it's already in Traefik. Please keep in mind that it's an experimental feature, so you need to be careful with implementing that. And I think that's all in regards to the slides. We can prepare for the demo, and let me close that, and let's go to, here is the link that I mentioned in regards to the performance in HTTP3, so you can have a look on it. You can go through it and explore more what's happening in that protocol, why it's so important. But let's go back to my demo. So I will start with a few examples. So we will deploy Traefik using the Helm chart. We'll deploy sample application. We will try to explore what is new in the 1.22 Kubernetes related changes in regards to the API version. And we'll go to the nested health checks, and we'll see how the local provider plugin works. So let me start from the beginning. I'm already connected to my Kubernetes cluster. So cluster there is nothing deployed yet. So we will go to first example, and we will explore what is inside. So I will use Helm, as I already mentioned. Let me make the font bigger. I think it will be better. So that's the values.yam file that will be passed to Helm in order to install Traefik. So we can pass some attributes just by enabling Kubernetes CRD, allow cross namespaces, and some specific additional arguments that are related to TLS challenges, and having the Let's Encrypt integration. And what is important here, we will enable Ingress class true, and some prerequisite for the that PVC that will be created. And let's try to deploy it. So Helm, let me move it a little up. So that command, let me first create the namespace. Create apply f namespace. So I will create namespace in my Kubernetes cluster. I will switch to that namespace. Nothing is deployed here. So let me deploy Traefik using those values that I'm just presenting here. So release does not exist, so Helm is going to installing. So we should see that Traefik has been just deployed. We can describe the deployment to see what are the CLI arguments that are, some of them are taken from that part, and some other are taken from as a default arguments. So we see that it's already added. PVC has been created. It's bound to the cluster. Yeah, Traefik is running. It will be available in a second. Yeah, it's up and running. We can see whether dashboard is available. So we can go to localhost to see if the dashboard is up and running. Yeah, dashboard is up and running, so we are good. Traefik is started correctly with two providers, Kubernetes Ingress and Kubernetes CRD. And because I enabled the Ingress class, we can see that Ingress class objects has been created. So as you can see, it has been created. We can use that resource in our configuration by creating the specific Ingress object. Let's describe it to see Ingress class. Yeah, let's get OYAML. And as you can see, the API version has been changed. Yeah, so it works, right? And it's up to date with 1.22 Kubernetes. Nothing has been changed in the spec, so you can just define the controller and the name of the Traefik if you are going to use that Ingress, if you are going to use Traefik as an Ingress controller in your cluster. So Ingress class, just explaining what is the Ingress class. So you can have a more than one Ingress controller deployed in a cluster, and having an Ingress class, you can specify what Ingress you are going to use to expose the service. So in my cluster, I deploy just only Kubernetes, so I will be pointing to that object in my Ingress object that I will create it just in a second. And as you can see, it's not default, so I have to specify explicitly in my Ingress object to say to the Kubernetes, yes, I would like to use Traefik as an Ingress controller. So now let's deploy some sample application that we will be used later on for nested health checks. So what is inside? So we create a standard Kubernetes namespace and deployment that will have that deployment will again deploy well-known who am I application, but with some changes. So there will be two applications deployed. The first one will be displaying the header in the response foo, and the second application, who am I, will display bar, and it will be needed for we will be using those deployment for creating nested structures. So let me deploy it. So namespace is created. Let's switch to that namespace. Let's deploy the 0.1 deployment. As you can see, application has been created, and now we can create the Ingress route in order to access that application. So it will be, those applications will be reachable using that URLs. So let's apply it. 0.3. I think that's correct. But before doing that, we need to update DNS. So let's get back to the Traefik namespace. Let's explore the service, load balancer service. And let's get to the curl. Let's execute that command. Update the DNS entry to that new load balance service created on AWS. So it will take a few seconds. It's all the wildcard record has been created. So each domain that we create will use that domain. So yeah, 03. Okay, it's fine. So let me apply it. Kubernetes app 03. So objects has been created. We can go back to the dashboard to see port forward. Let me refresh it. Yeah, dashboard is back again using the port forward, and we should be able to see those two new objects that we have been created. So nothing new here, but yeah, it works. It's good that it is working. So if we go to the HTTPS v1 www demo-k, we have foo, and here we should have a bar. So the application, those two applications are deployed correctly. We can reach them using the external URLs. And we will be using those services later on while presenting nested health checks. So now we can go to another example when we will just explore new Ingress objects that are matching the changes related to Kubernetes 1.22. So as you can see, that's the new spec, new object using that API version. The name is Ingress. The kind is Ingress. The name is example Ingress. It will be running in the namespace app. Following annotation will be passed to talk with a Traefik, and Ingress class name Traefik. So we will instruct the Kubernetes to use Traefik as an Ingress controller to expose that application to use for that URL. So let me try to deploy it. Apply of Ingress. So the object has been created. ing-a. So as you can see, it's running in the namespace app. The name is example Ingress. The class is Traefik, and the host is v3, and the port is 80. So once we will go back again to Traefik namespace, to the we should be able to see the new v3 has been added. So nothing new again from the user perspective, but it works, right? But it used the new API version, and then for Ingress object as well as for Ingress class. So you can be safe while you're deploying 1.22 Kubernetes and Traefik 2.5. So you can be sure that it will be working correctly. So now if we will go to the curl HTTPS v3 demo Traefik labs.tech-k, we should see the application. Yeah, so it works correctly. We can see that the all headers are correctly exposed. The application is running fine. So that's good news. It works on 1.22 with the new API version. The next feature that I'm going to show you is actually that one that I like the most. It's the nested health checks. And it's a little bit tricky because, as I mentioned, it works for now only with file provider. So we need to deploy config map with a specific configuration. So this is that configuration. And it's part of the dynamic configuration in Traefik, and it will create the some nested structures. So let me go from the that will deploy the whoamidc service that will point to that Kubernetes service that is running in the namespace app, and this is exposed by deploying that sample application. Same is done here, but the name of the service is DC2, so we can think about it. It's totally separate URL, not related to Kubernetes, because this is only reachable inside the Kubernetes cluster, but you can have a URL can point to anything else that is even outside your Kubernetes cluster. And Traefik is able to check what is the condition of that health check using the standard health check dedicated for that application. And if that health check is failing, Traefik will not pass a request to it. However, why? Actually, because it's using the weighted round robin. As you can see, we have a whoami public service, and it creates then object weighted, and it used two services, whoami DC1 and DC2, and it used weights here. So 3 to 1. Some of the requests will go, most of the requests will go to the whoami DC1, and some of them will go to the whoami DC2, using actually those flags. And because we have a health check feature here, so if one of those services is down, Traefik is able to discover it and will not send the request to it. So if you use any legacy application, you can use that feature in order to help you migrate to even to Kubernetes, because you can have some of your pods running in Kubernetes and some of them running in the old infrastructure. But Traefik can be running on Kubernetes, and you can create routing between external URLs here. And the router looks like following. So we have a whoami router that use that nested URL and that service whoami-public. So everything what will match the rule using that HTTP host header nested will be routed to the whoami service public. And that's the definition. It's the weighted, and it will go to whoami DC1 and DC2. So that's the very cool feature. Let me deploy it. So first I will create that config map in my cluster in namespace Traefik, and I will enable in my values.yaml, I will enable the volume, because Traefik needs to mount that volume with that config map to the Traefik pod. And we also need to add an additional arguments to talk to Traefik using the that dynamic configuration where it's where that config map will be mounted. So let me do that. So the first step is, let's go to the 04 nested health checks, and we need to deploy the Traefik config map. So it is created. I got the config map has been created. Describe CM Traefik. As you can see, all those configurations already in my Kubernetes cluster, and now we need to redeploy Traefik using the new values.yaml file in order to enable that provider and that and mount that config map. So let me do that. Let me upgrade install Traefik. Yeah. So it is deploying right now. Yeah, Traefik has been redeployed. As you can see, the pod is terminating and the new pod using the new replica set is just starting. So we can describe that object to see if the new provider has been added. Yes, the new provider has been added. The config map has been also correctly mounted. So I think we are good. We can now go to dashboard to see the configuration. So let me run port forwarding once again. As you can see, nested router has been created. It uses a file provider. So entire definition is actually placed in that file. And as you can see, who am I public is the service has been created, is awaited, right? And it used the DC1 and DC2. So those two new services that I've been created. And now if we go to the nested, that external URL, we should see foo and the bar in the response because of the weights we define in the static, in the dynamic configuration in the config map. So if we explore who am I public in details, we can see that there are a who am I DC and who am DC1 and DC2 with those specific weights. And the URL is nested WAW demo Traefik labs.tech. So let me try to call that that URL. Foo and bar, yeah. So based on those weights, Traefik is able to randomly route incoming network traffic and send it to the services using actually those weights. But what is the cool feature here? If I will now scale down one of my let me go to the Kubernetes to the app namespace. Let me now scale down the service. Let's try to make that who am I v1 unhealthy. So we will scale down deployment who am I to 0 replica. As you can see, it's scaling down. And now if we will go to the nested, we should see only bar response without affecting the end URL, the users, right? So we are just getting only bar. So that's the expected behavior. So Traefik was able to discover, okay, there is a change. Something is happening on the DC1. So I'm not going to send network traffic to that unhealthy service unless it will be healthy back again. So let me try to do scale it up. Oh, not 22. Okay, let's run it 2. So I ran it too much. And it will be healthy in a few seconds. Yeah, v1 is already available. So now if we'll go back again to that URL, we should see the same round robin between those two DC1 and DC2 services, the same behavior. So again, we have a foo and bar. So that's the cool feature, and I really recommend you to try to test it on your site using file provider. And yeah, in the future, it will be available as a regular CRD. So you can use an Ingress route that is well known and well used in Traefik ecosystem. So that's definitely you should try it. Yeah, and the last feature that I'm going to show you, it will be running on the Docker Compose because it will be easier for me to work on it. So what you have to do here, It's very simple Docker compose file that we map the volume plugin provider that is actually source code of that provider demo that is released on our GitHub repository, Traefik plugin provider demo. So Traefik will be able to use new provider as a plugin. So you need to just enable that example provider using that command, CLI command here, and a use experimental feature to tell Traefik use the local plugins. The name is example provider, and the module is running in that specific location. So let me do that. I should have Docker up and running. Yeah, it's up and running. So let's do Docker compose up, not down, of course. Okay, it's getting started. Configuration received from the provider plugin example provider. So that's the information that everything is running successfully. Traefik is able to read the source code that is available here, and we should be able to reach the dashboard, the new dashboard here, and see that localhost that provider plugin is available. Let me go there. So as you can see, that's the new icon available here, and it's the providers, and that's the name of the plugin provider that we just added for the local development, for local usage. And we will go here, we'll see that there is some new examples added, some new entries added, new routers added, new router created using actually that new plugin provider that we have just added. So yeah, I think that's all what I prepared for today. If you have any questions, I'm happy to answer.
Wonderful demos, Jakub. Really interesting, a lot of the thing. And one thing I really noticed with the 2.5 release is that
Yes.
the migration of the legacy app. So drop
Yeah.
some point to the audience why that's important. Because might be you are running some part of your application outside the Kubernetes environment.
Yes.
And you want to migrate your apps to the Kubernetes cluster. And what you just
Yes.
showed is now really easy and simple with few extra lines of the XAML file. How Traefik made it so simple and so easy for us.
Yeah, so that's the exactly the feature that is designed can help you with migrating to different to Kubernetes, because you can instead of using the Kubernetes service that I used in my example, because I was referring to the Kubernetes service for WhoAmi application, you can use URL that is pointing outside your infrastructure, Kubernetes infrastructure, Kubernetes cluster. And you can, let's say you have an entire application deployed there and you are preparing to the migration. So you can deploy Traefik on Kubernetes, and you can use the endpoint of your application in that nested structure, and most of the incoming traffic you can redirect to that legacy server. In the same time, you can try to deploy your application in containers, in pods on Kubernetes, and use, let's say, waits to 100 requests goes to the application on the legacy server, and just only one request goes to your application on Kubernetes. And you can see what's happening, what is the behavior, how it's what are the logs, how your application behave in that new environment. So that's a cool feature, and I like it very much. It might be also used you don't have to point to the legacy server. You can point to another data center with another Kubernetes and another traffic running there. So it's all up to you. But this is actually one of the use cases.
Yes,
and
absolutely.
if something is wrong with your application, I mean, let's say there are some issues, traffic will not pass the request there. So it's not that just a request that is not just passing request to the service, but is able to check, is it healthy or unhealthy? And in case some issues, it won't send traffic to that service.
Yes, absolutely. I think that's really a wonderful feature with the 2.5, because a lot of the time, like people like us who build down some innovative solution to doing this kind of stuff in it, just to check how my application behaves within the Kubernetes cluster, because I am a customer, haven't used Kubernetes before. So I am having 90% of the apps written outside the Kubernetes environment. Now I want to use Kubernetes cluster to check how my application behave. And the same, and that's a really easy step forward, because we don't add any extra layers on top of it. It's just Traefik Proxy that you have existing knowledge of it. So that's really wonderful.
Yeah, you can deploy proxy on Kubernetes, and you can, from that point, you can start using Kubernetes and moving further with your migration. So that's the one of the use case. Of course, there are much more depending of how your environment is complex, how many applications you deployed, and what's the, there are no one regular solution, but that's something that, as an example, you can start exploring that feature from that point.
Yes, absolutely. And I think another cool feature that you just shows up, that Traefik is checking the health check. Let's say one of the applications down and it's not sending traffic to it. So talk us more about this feature that you showed up. How important is that routing traffic to the services need to be health checked, need to be monitored, that they're up or running all the time?
Yeah, so that's, as I mentioned earlier, so that health check is, it's health check that is able to read responses from the nested structure, because I added health check features on my service. And in the public service, I just defined the structure health check, and it informs traffic that you need to check what is the condition, what is the healthy, is it service that I'm going to send traffic to is healthy? Is it healthy? Yeah, I'm going to send it. If there are any problems with that, I'm not going to send it. So that's the important stuff, because it's not just a service that is always send traffic and you might affect your users, but in case if the health check is able to check what is happening deep in your infrastructure on your end URL.
Yes, absolutely. I think during the first version of the Ingress controller when come up in the market, people liked a lot of the script to check the applications are healthy, like the startup time, the health responses. Like they've done a lot of the configuration, and that's really makes the YAML file so giant, so huge, and it's looking like a very difficult to understand what's happening in there, just to ensure the responses from the server that it's always maintained. And now with a few 3-4 YAML files, we can check how to ensure. That's really another wonderful feature from the Traefik. I think a lot of the customer like about it, because we get rid of the huge script. I have gone through that scenario where we'll run out the huge script just to ensure the HTTP responses are come up from the 200 OK, not the 404 or 500 responses from the server. And now it's the job of the Traefik, and you feel relaxed about it. Don't ever type these extra script on the future releases of the Traefik. So before I let you go, another question, another wonderful cool feature you can focus about is a plugin. One of the examples you showed us today. What are the other use cases do you think about the plugins? You can add more plugins on the Traefik and then see on the dashboard that another plugin is added to the Traefik, and you get rid of, you want to go through and drill down what's happening in there. What do you think? What are the more use cases for the plugins?
Yeah, so the plugins are, so first of all, if there's, you can think about the plugins that if there are no feature in Traefik, you can code your own plugin and you can address the need you have. And that's why that community in Traefik Pilot is growing. There are a lot of plugins that provides a very nice feature. As I mentioned earlier, examples are JWT authentication, JOT token, fail to ban. So it's very similar to the old times with when you use IP tables and fail to ban to block your request. So the same similar behavior might be done on the HTTP using actually that plugin. So it's a middleware that use a plugin inside the so you can code everything actually you need. Another feature is a provider, so you can integrate Traefik with actually other other provider of the configuration. So as I mentioned as an example, Microsoft Service Fabric. So one of our friends is working on it from Microsoft, and they are developing that feature actually to Traefik using that plugin. So you can code your own provider if you have any special use case. So you can code your own provider and add it as a plugin locally from your local environment, and you don't have to use Traefik Pilot for that. You just need to use similar configuration that I presented in the demo.
Yes, absolutely. I think a lot of if people are been to the KubeCon LA, in this KubeCon is all about supply chain security and the key signing part of it.
Yes.
Might we will see in the future in the Traefik, we have some keyless signing infrastructure built in using the provider plugin, and when you authenticate to the server, all the certificate rotate while making the connection and revoking the certificate, because key signing is really easy right now because of the cosign tool and some of the other tools available on the market. So I think hopefully we can use a plugin in this way as well moving forward. But I think that's a really good approach that the Traefik community is going to follow, because a lot of the innovation happening outside the Traefik as well. How do we integrate those innovation into the Traefik dashboard is through a plugin that we can invent more and more cool feature in it.
So now you have that freedom that you code everything what you want, and it might be added to the Traefik. So that's the possibility. So we believe that our great community will surprise us with new features and new provider plugins. So that's why we released that feature.
Yes, absolutely. And everybody who listening to this or watching this session from the YouTube, tell us on the comments what you feature like most and what you see next in the future, and what you think about how you're using Traefik today in your cloud native stack. We're really eager to know about. And if you find us some feedback around the Traefik, what the new features you are looking at, ping us on Twitter, me or Jakub, or join the Slack channel or join the community. We will love to hear your feedback, and we will work on these feedback that you are suggesting to us. So thank you very much, Jakub. It's been a wonderful session with you. Always enjoy the time spending with you. So before I let you go, the final question: how you spend your weekend how you spend this weekend coming up?
The weekend that is just coming, right?
Yes.
The new weekend. Yeah, so I will spend with my son because my wife is going to the university, and I will be full-time dad. So I'm very happy because we have some outdoor activities with my son. So I'm very excited, and I can't wait to do that.
Yes, absolutely. The parent duty is coming up for this weekend. But thank you very much, Jakub, for joining me today.
Thank you.
Always
thank you, Sam.
Enjoy the time. Thanks everyone who showed up
Thanks
for
a
this
lot.
session. Bye-bye.
Thank you a
Stay
lot.
safe, stay healthy. Hope to see you again in the next Traefik Islamabad meetup.